On July 12, 2000, on the Greek island of Crete, 143 passengers and 8 crew members boarded an Airbus A310 operated by Hapag-Lloyd Flight 3378, bound for Hanover, Germany. Just before 11 a.m. local time, Flight 3378 pushed back from the gate at Chania Airport, preparing for its non-stop flight to Germany. The captain, Wolfgang Arminger, was 56 years old and had more than 23,000 hours of flight experience. He was one of Hapag-Lloyd's most experienced pilots. According to the accident investigation report, the first officer, Torsten Alvaren, was a relatively new pilot at the company with only a few hundred hours on the Airbus A310. When the Airbus A310 was first introduced in 1983, it was hailed as an engineering marvel, one of the first jetliners that could be operated by just 2 pilots. However, by the year 2000, most airlines had already begun phasing out the A310, replacing it with the more modern and fuel-efficient A33. Shortly after 11 a.m., the pilots taxied the aircraft onto the runway and began their takeoff roll. But just seconds after liftoff, they encountered a problem. When the pilots moved the landing gear lever to the up position, multiple system warnings appeared, indicating that the landing gear had failed to retract properly. The crew tried several times to raise and lower the gear, but the problem persisted. Although this was an abnormal situation, it did not qualify as an emergency. The aircraft could safely continue flying with the landing gear extended, but doing so caused enormous aerodynamic drag, forcing the engines to run at higher power and burn much more fuel. The pilots now had to determine whether they had enough fuel to reach Hanover or if they needed to divert to a closer airport. The captain asked the first officer to contact the company's operations control center for advice. Normally, such communication would take only a few minutes, but the first officer soon discovered that Hapag-Lloyd's remote radio communication system was not working properly. With radio communications unavailable, the first officer had no choice but to use a more primitive text-based system, ACARS, to contact the operations center. However, communication through ACARS was painfully slow. Each exchange of messages between the cockpit and the dispatcher took several minutes, and the entire conversation dragged on for nearly an hour. Meanwhile, the captain began calculating their fuel requirements. To do this, he used the Flight Management Computer, FMC, the same system the first officer was using for ACARS messaging. The FMC factored in several variables, including wind speed, aircraft speed, weight, and cruising altitude, and used these to estimate total fuel consumption. Based on the data, the FMC provided a figure known as the predicted fuel remaining, an estimate of how much fuel would be left upon reaching the destination. By checking the FMC, the captain quickly concluded that the aircraft did not have enough fuel to reach Hanover. He informed the first officer, who then relayed the information to the company dispatcher. The dispatcher suggested they divert to Stuttgart in southern Germany, but the crew believed that Stuttgart was still too far away, so they proposed Munich instead. This plan was approved, and the dispatcher added that if Munich later appeared unreachable, they could divert to Vienna, Austria as a backup option. Hapag-Lloyd Flight 3378 continued climbing, eventually leveling off at a cruise altitude of 31,000 feet. The crew then began a more detailed assessment of fuel consumption. The first officer took out the flight manual and turned to the section about extended flight with the landing gear down. In that section was a chart showing fuel consumption at various speeds and altitudes, but the chart only went up to 27,000 feet. Since they were already flying at 31,000 feet, the captain assumed that the chart's limit was only for flight planning purposes, not for in-flight calculations. He believed the flight management computer's figures would be more reliable, so they put the manual away. Neither pilot yet realized that their core assumption that the FMC could accurately account for the increased fuel burn caused by flying with the landing gear extended was completely wrong. Unlike a car's fuel consumption calculator, the Flight Management System, FMS, especially on older aircraft like the Airbus A310, does not calculate future fuel use based on real-time consumption. Instead, it relies on an algorithm that estimates fuel burn by considering variables such as altitude, airspeed, and wind conditions. Using this data, the system predicts the remaining fuel at each waypoint along the route, including the destination. But there was one crucial flaw. The algorithm did not account for whether the landing gear was extended or retracted. This meant that the computer had no idea the aircraft was burning fuel at an abnormally high rate due to the huge drag from the extended gear. The system simply assumed the plane was flying normally, with the gear up, and therefore produced wildly inaccurate fuel predictions. During their first ACARS exchange with company dispatch, both pilots checked their individual FMS units and reached the same conclusion: the aircraft could still make it to Munich. At that point, the system estimated there would be 3.3 tons of fuel remaining upon arrival, comfortably above the minimum legal reserve. However, just before noon, the first officer performed a routine manual fuel check and discovered that their actual fuel burn was 60% higher than expected. The massive drag from the lowered landing gear was dramatically increasing fuel consumption. Strangely, the pilots did not realize that this meant they would never make it to Munich. Their decision to continue was based on a logical but flawed assumption, that the climb phase always consumes more fuel than cruise and descent. Because of that reasoning, they ignored the clear discrepancy between their manual calculations and the FMS's optimistic predictions. They did not investigate the root of the problem further. As the aircraft crossed southern Europe, the FMS's projected remaining fuel on arrival at Munich kept dropping steadily. Initially, it predicted 3.3 tons, but soon that number fell to 2 tons. The FMS algorithm itself was functioning correctly. It was simply being fed unrealistic assumptions. Since the actual fuel burn rate was far higher than normal, the system's estimated remaining fuel continued to decrease. According to aviation regulations, an aircraft must have at least 1.9 tons of fuel upon landing. By this point, Flight 3378's remaining fuel was less than 100 kilograms above that minimum threshold, dangerously close to empty. At this point, the captain decided to change the destination to Vienna, Austria, since Vienna was closer than Munich. When he set Vienna as the new destination in the flight management system, the computer estimated that the aircraft would land with 2.6 tons of fuel remaining. That seemed sufficient, but only barely. To increase the fuel margin, the captain requested direct routing from air traffic control, hoping to shorten the flight distance and save fuel. It was a cautious and sensible decision, but it had an unexpected side effect. As the flight progressed, ATC kept giving them shorter routes. However, the system's projected remaining fuel upon arrival in Vienna stayed at 2.6 tons. It didn't rise, even though the flight distance had decreased. In a normal situation, such shortcuts would have increased the estimated remaining fuel. The fact that it didn't meant something alarming. The aircraft was burning fuel much faster than the system's algorithm predicted. If the pilots had been more alert, they might have recognized this warning sign. During this time, the aircraft passed east of Zagreb. It could have easily diverted and landed there, completely avoiding what was to come. But the captain chose to continue to Vienna. He knew that Hapag-Lloyd Airlines, the operator, had maintenance facilities there, which would make repairs easier. Having worked for the company for many years, he was also well aware of the commercial pressure to minimize delays and reduce the cost of rebooking passengers. From that point on, the route to Vienna was nearly a straight line, meaning there were no more opportunities to request shorter vectors. The true fuel situation could no longer be hidden. As expected, the flight management system began showing a steady drop in the projected fuel on arrival. By around noon, the estimated remaining fuel had fallen below the legal minimum requirement of 1.9 tons. Tension in the cockpit mounted sharply. The captain radioed Vienna Air Traffic Control, requesting a direct approach to runway 34, which was aligned with their current flight path. The request was approved, and he then asked for priority landing clearance, which was also granted. The first officer insisted that the captain declare a fuel emergency, as regulations required it whenever the estimated landing fuel dropped below the legal minimum. But the captain refused. He didn't want to cause public concern or bring trouble to himself or the airline. Just 6 minutes later, however, the low fuel warning light illuminated in the cockpit. Only then did the captain relent and declare a fuel emergency to air traffic control. Yet, puzzlingly, during this emergency call, the captain told ATC that they would be able to reach Vienna safely and that there was no need to station emergency vehicles along the runway. The captain seemed eager to downplay the seriousness of the situation, treating the emergency declaration as a mere formality rather than a genuine warning. Despite the worsening fuel situation, the crew still had several options to ensure a safe landing. First, they could have stayed at cruising altitude longer to reduce fuel consumption, then performed a power-off glide descent closer to Vienna. Instead, they began descending while still 267 kilometers from the airport. This meant the engines had to maintain relatively high thrust throughout the long, gradual descent, burning even more fuel. A better alternative arose at 12:09 p.m., when the first officer suggested diverting to Graz Airport, which was 55 kilometers closer than Vienna. But the captain rejected the idea, arguing that the aircraft was already lined up for Vienna and that turning towards Graz might actually consume more fuel. His reasoning was flawed, yet the two pilots briefly assessed the possibility of diverting. In the end, they abandoned the plan. They couldn't find the approach charts for Graz Airport and decided to continue toward the more familiar Vienna instead. As the aircraft continued its straight-in approach to Vienna, the flight management computer's estimated remaining fuel kept dropping. The situation finally drew the captain's attention. For the first time, he questioned whether the flight management system had accounted for the extra drag from lowering the landing gear in its fuel calculations. The first officer immediately and correctly replied, it had not. However, the captain still refused to accept reality. The first officer, helpless, gave up arguing. A few minutes later, at 12:26 p.m., when the aircraft was only 22 kilometers from Vienna Airport, the right engine flamed out. Just seconds later, the left engine also shut down. The aircraft had completely lost power. It was now a massive, powerless glider, silently descending toward the ground. To maintain minimal control, the captain deployed the ram air turbine, a small emergency fan that generates limited electrical and hydraulic power when all engines fail. This allowed the basic flight instruments and control systems to keep functioning. The first officer immediately radioed air traffic control with a mayday call and began one last attempt to restart the engines using whatever fuel might be left in the tanks. Miraculously, the restart worked. Both engines came back to life for about 2 minutes before dying again. The fuel was completely gone. At their current descent rate, the captain couldn't stretch the glide far enough to reach the runway. At 12:30 p.m., the aircraft crash-landed in a field about 660 meters short of the runway. The left wing and landing gear struck the ground first, snapping the left landing gear assembly. The plane skidded sideways through the field, the left engine scraping a long scar into the soil. It then plowed through a runway approach light, hit a navigation antenna, crossed a taxiway, and finally came to a stop. As soon as the aircraft stopped moving, the captain ordered an immediate evacuation. The flight attendants began directing passengers to escape. Although all 143 passengers survived, with most escaping uninjured, the evacuation was chaotic. The front left door couldn't be opened because of the aircraft's tilt. The front right door was too high above the ground for passengers to jump safely. The two mid-cabin slides also failed. The left one was punctured by debris, and the right one was blown onto the fuselage by strong winds. In the end, everyone evacuated through the two rear exits. Fortunately, there was no remaining fuel, so no fire broke out. A total of 26 passengers sustained minor injuries during the evacuation, while everyone else escaped unharmed. The aircraft, however, was severely damaged and written off as a total loss. At first, the captain was praised by the media as a hero for his successful emergency landing. However, when Austrian investigators examined the black box recordings, they discovered that the captain's public claim that the plane had suddenly run out of fuel during its final approach to Vienna was false. In reality, the aircraft had been gradually losing fuel throughout the entire flight. As for the initial cause of the landing gear problem, investigators found that a single misinstalled nut on the actuator of the right main landing gear had mechanically prevented the gear from retracting properly. The focus of the investigation then shifted to a deeper question. Why were the pilots so confident that the flight management computer, FMC, could accurately predict the fuel remaining at the destination? Investigators discovered that the pilots had received very limited training on the FMC. They had only learned how to operate it in a few standard scenarios, but had never been taught how the system actually worked. They didn't realize that the FMC used predictive algorithms to estimate fuel consumption, rather than performing a real-time linear calculation like a car's onboard computer. Later, the captain explained in a media interview, "I thought the flight management system was like a car's computer. Even if you put a roof rack on the car, it would still calculate the correct remaining range." This misunderstanding revealed a deeper issue. The aircraft's operations manual did not clearly list the specific parameters or logic the FMC used to calculate fuel estimates. Had the pilots had access to that information, they would have realized that the increased drag from the extended landing gear was not included in the fuel consumption calculations. The investigation also found another contributing factor. The Airbus checklist for flying with the landing gear extended originally included a step requiring manual verification of fuel levels. However, the version issued by Hapag-Lloyd Airlines to its pilots had omitted this step. All these factors combined led to the captain's early and ultimately fatal assumption that the FMC's predicted remaining fuel already accounted for the extra drag caused by the deployed landing gear. In truth, it never did.
This mistaken assumption went unnoticed and unchallenged throughout the flight because air traffic control kept granting the crew shortcuts that made the fuel estimates on the flight management computer appear stable. It wasn't until the final minutes before reaching Vienna that the true fuel crisis became apparent. The final accident report concluded that the captain was psychologically influenced by perceived benefits of continuing to Vienna. Even though both Zagreb and Graz offered safe diversion options, they were, in his view, less ideal. Under intense pressure, the captain clung stubbornly to the original plan, even when it was no longer rational, and refused to accept safer alternatives. The first officer, on the other hand, demonstrated professionalism and sound judgment. He remained open-minded and repeatedly offered reasonable and valuable suggestions, though unfortunately none were accepted. Investigators also found that after both engines flamed out, the crew did not follow the proper emergency procedures. Had they activated the landing recovery system and deployed the slats and flaps as prescribed, the aircraft might have been able to reach the runway safely, avoiding both injuries and the loss of the aircraft. Although the accident resulted in no fatalities, it had a profound impact on pilot training and aviation procedures. It led to stronger emphasis on collaborative decision-making, psychological resilience under pressure, deeper understanding of flight computer systems, and updated emergency operating protocols. In the end, this event was regarded as an extraordinarily lucky lesson, one that reshaped how pilots and airlines approached safety, teamwork, and trust in automation.